If we want to find the area of these strangely shaped regions, we can break them down, these regions we can break down into various pieces that we know how to find. This says find the area, so I'm going to be using the area of these other pieces. You can see this first one, this almost looks like you're talking about a bolt with a hole, typical hole drilled through it. If you're trying to figure out the weight of a bolt, you might be interested in this area, because we'll talk about volumes in the next chapter. But if you use the area times the height, that could give you the volume. In any case, we're trying to find the area of this guy, and well, we know the area of a hex. We know the formula for area of a hexagon. And you can see this bigger hex, if I subtract off the area of the inner circle, this will give me the area that's shaded right there, the area that's in blue. So I need to figure out the area of the hexagon and the area of the circle. Well, if you remember back when we talked about hexagons, I'm going to go ahead and use the approximate version of the area. The area of a hexagon is 2.598 times a squared. A is the side length. I'm just copying this down from what we saw before. The area of a circle is pi times r squared. Looks like r in this case is 1/2, so instead of writing r there, I can write 1/2. Oh, actually, I guess, yeah, let's do r here. This is the radius. Fortunately, you can see we're given exactly the side length of the hexagon and the radius of the circle. Those are the two things that we're given, so there's not very much we need to actually do here. I can just plug stuff in. This will be 3/4 squared minus pi. I'll just let my calculator put that one in there, times 1/2 squared. So let me pull out the calculator. We'll go 2.598 times 0.75 squared minus pi, or 3.14159.265. I would recommend just pressing the button on your calculator. Unless some of the questions, you'll notice when you're doing the homework, some of the questions say use the value 3.14 for pi. Follow the instructions, of course, if you're told to explicitly use a particular value. But in general, I prefer to just use the button on the calculator because it's more accurate and it's faster. So minus pi r squared, we end up getting 0.67597, whatever. I will say that this number right here has been rounded to 4 significant digits. If I wanted to go with more than 4 significant digits for this value that I got here, I would need to use the non-rounded version of this number. And just a quick reminder, this was, what, 3a squared, square root of 3 over 2. So this 3 times the square root of 3 over 2, that is approximately this 2.598, whatever. If I wanted to go with more accuracy, I'd have to use this instead. But I think 4 significant digits is generally going to be plenty, especially if we're, well, for most any measuring instrument. So we get I'll just go, let's say, 3 significant digits. Yeah, whatever. I don't know. I don't really see any indication as far as where to round here. So I'll call this 0.676. When you're doing the homework and the test, there should be an indication of where you should round. If it's during a test and I don't indicate where to round to, that means I'm not assigning any points to it, and that means I'm giving you the choice as far as where to round. So just do whatever you think is reasonable on those ones. All right, so on this shape right here, this kind of looks like we have a rectangle and then a semicircle, a half circle here. So if we're trying to find the area of this guy, what I would do is I'd figure out, okay, what's the area of the rectangle, this spot right here, and then add on the area of the half circle, this bit right here. So let's see, the area of the rectangle plus the area of the half circle. Technically, it's called a semicircle, whatever. If you want to call it a half circle, I wouldn't really care. All right, the area of the rectangle is pretty easy. This is 9 feet by 24 feet, so 9 by 24. To find the area of a rectangle, we just take length times width. To find the area of the half circle, we need the radius. we have the diameter. We know that it's 9 feet across from here to here. So that means the radius would have to be half of that, which is 4.5 feet. We just took the 9 feet, because the distance, if this is a rectangle, this distance right here is the same as this distance right here. That's how I know that this one should also be 9 feet, and thus the radius would end up having to be half of that, or 4.5 feet. So the area of the rectangle is 9 times 24. The area of the semicircle is pi times 4.5 squared. And, well, yeah, whatever. It's just a matter of plugging it into the calculator from there. You don't need to see me do that on these, I don't think. Alright, actually I probably should, just so you can verify that when you plug it into the calculator, you get the same number as me. So you can verify that you're plugging it into the calculator correctly. If you haven't been doing that on all of these other ones, you should be. Alright, so 9 times 24 plus pi times 4.5 squared gives me 279.6 something. I don't know. I'm going to go ahead and just round this to, let's call it 280. This is in feet, that's in feet. The radius was in feet. Everything is in feet. So this ends up, since it's an area, it ends up being in square feet. You can see 9 times 24, that would be measured in square feet, because we're taking feet times feet. 4.5, when we square that feet, that would be measured in square feet. Multiplying by pi doesn't have any units, so we're taking square feet plus square feet, we end up with square feet. So everything does end up working out there. Alright, looks like this one, an upside down ice cream cone. I don't know, whatever you want to call that. But actually it looks like this has an equilateral triangle. Remember your vocabulary here, equilateral. Lateral meaning side, equa meaning same distance, or the same. So all 3 sides of that triangle are the same, thus it's an equilateral triangle. And when we're dealing with an equilateral triangle, we can use the formula area equals 4.33a squared. Actually, let me do it this way. That's the approximate version of the measurement. If we want to go with the exact version of the measurement, I'm just looking at a sheet here. We get a squared times square root of 3 over 4. But the easier thing to do here would be to do 4.33a squared. This square root of 3 over 4 is approximately 4.33 if we round it to the thousandths place. Alright, so that would be the area of the triangle. To find the total area here, we're going to take the area of the triangle and add on the area. Oh, you know what? I just realized I made a mistake on this last problem, because this was supposed to be a semicircle. That should have been times 1/2. I should have only been doing half of that, which means this was an error. Fortunately, on my calculator, I still have it typed in there. I'm going to do times 0.5 times. I'm going to tack that on. This should be 247.8. We'll call it 248. Let me double check to make sure I didn't make that same mistake on any of these other ones. Unfortunately, that's a pretty easy. Oh yeah, okay. So this one was a full circle. That one's a half circle. This one is going to be a half circle, though. So this will be the area of the semicircle. So we're going to do the area of the triangle is 4.33a squared. A is the side length. Plus half the area of the circle. I'm not forgetting the half this time. 1/2 times pi times r squared. And if we have a this distance right here, if it's 12.8, then half that distance would be our radius, which would be 6.4, it looks like. So that means we have 0.433 times 12.8 squared plus 1/2 times pi times 6.4 squared. So 0.433 times 12.8 squared plus 0.5 times pi times 6.4 squared. So I get 135.28 something. I don't know, I'm going to go ahead and call this 135. These were all measured in centimeters. The areas would be in square centimeters. This one right here kind of looks like the second example, this one right here, except it doesn't look like this is a semicircle on this side. It looks like these corners have just been rounded over with a 3-inch radius. I say that this is a radius because this would be the center of the circle here, and we're going from the center of the circle to the outside. That's how we measure a radius. So if I'm talking about the total area of this guy, I would probably do the area of this rectangle, and then I do these 2 quarter circles, and those look like they're actually the same. And then there's this rectangle here, which I'll call rectangle 2. So to find the total area of everything, I'm going to say the area of rectangle 1. I'm going to add on 2 of the quarter circles. I could say the area of the quarter circle plus the area of the quarter circle, but they're the same value. They're both 3-inch radius circles, and they're both a quarter of them. So I'm just going to double it to get the sum of the two. And then we have the area of the smaller rectangle. So now I just need to go through here and figure out, okay, what are the dimensions of each of these? This first rectangle here, it's definitely 10 inches in this direction right here, but this direction right here is not given. However, I do know that this total distance is 25, and if I come back 3 inches, that's where I get to the beginning of my rectangle. So, or the end of my rectangle, I guess, whatever. So this would be a 10 by 25 rectangle. So the area of that rectangle is 10 by 25. Let's see, I'm going to say 2 times the area of a quarter circle. Well, if I'm doing the area of a quarter circle, let me do parentheses here. That means 1/4 pi times r squared. I need my radius. Unfortunately, that's already given as 3. And the area of my rectangle 2, well, let's see. Let me kind of zoom in on this. We have our 2 quarter circles here. We know that this distance is 3 inches from there to there, but this distance right there I don't really know. However, I do know that this one is 3, this one is 3, and that this total thing is 10. So, well, there's 6 of the 10 already taken into account, there and there. 10 minus 6 is 4, or however you want to do that. You could say 3 plus x equals 10. Whatever, we get x equals 4. This would have to be 4 inches here in order for that total distance to be 10. You could do 10 minus 3 is 7, minus 3 again is 4, and that gives you the x. I don't know. So in any case, this the area of this smaller rectangle, this one here, this looks like it's a 4 by 3 rectangle. 3 by 4, 4 by 3, whatever. And yeah, that looks like that's enough to plug into the calculator. We have an area of 250 for the first. 10 times 25 is 250. We have 2 times 0.25 times pi times 3 squared is 9. That's the area of the 2 quarter circles. And then the area of my second rectangle, this 4 times 3 is 12. Press enter, we get 276 approximately. 276, and everything here is in inches, so since this is an area, it'll be 276 square inches. I was not being very careful with how I'm rounding on these, obviously, because I'm not given any instructions on how to round.